what form is the function f of x is equal to 1 divided by x squared minus 4x plus 3 written in? So we want to keep in mind that it looks like we have a quadratic function here, right? I mean, it looks like it. We have something that follows the standard form very closely down here on the bottom, right? Recall that the standard form of a quadratic function is going to look just like this, where it has some leading coefficient of a multiplied then by x squared plus some coefficient of b multiplied by x plus some coefficient of c. Now remember, the coefficients are just going to be numbers. The that was a mix between important and term. So let me try to separate those words. The most important term is going to be the x squared. Okay, your quadratic function must have an x squared in it, and if you must have at least x squared and no more than x squared. Okay, so that's looking actually good for right now. There are two other forms, but it won't be important for this problem because we kind of already see that we do have a standard form here. But it turns out that this is not in standard form. Okay, this is standard form, right? There's a difference between taking this and putting this under, or meaning in the denominator, putting it under 1. Okay, and the easiest way to kind of explain that, I think, is to look at pictures of graphs. Okay, we know that a quadratic function must have a parabolic shape. It must look like a parabola. And remember, parabolas look like this. They're either going to look like some smiley face, okay? It should be a little bit more symmetric. And it'll be symmetric about the vertex. In other words, if I were to draw a straight line down the middle, the left side should look very identical, or meaning symmetric to the right-hand side. And you should have this kind of nice hairpin turn at the bottom. You don't want it to come down and really flatten out. If it flattens out like that, not a quadratic, okay, not a parabola. So it either look like that where it's smiling at you, or it's going to look like it's frowning at you. One of the two, and it has to be the nice hairpin turn again, okay? And it should be symmetric, but whether this is over here or over there or up or down, that doesn't matter, okay? Now, the best thing to do then is to kind of graph this. Let's throw it into the calculator, and let's see what graph we get. And here it is. So when we look at this graph, we notice that we do have, I guess, some part down here that does look like a quadratic-ish, but the whole graph has to look that way, all right? We cannot have these two components inside of this graph and call it a quadratic function, all right? The whole graph has to be just this and only that. So we can definitely see from a graphical perspective that this function up here is definitely not a quadratic function. So actually, this function, therefore, is not in a quadratic form. And sometimes it's just easiest to tell from a graphical perspective. So never forget that you have that, most likely will have that ability. We've done a lot of examples here through looking at just the algebraic form. And we kind of talked that, this quadratic form, even though it's in the denominator, overall the function is not a quadratic function. Okay, it cannot be in the denominator. If I were to bring this denominator out and bring it into the numerator, I would have to wrap the entire thing in a parenthesis and raise it to the -1. So again, that's not a quadratic function. It doesn't follow that standard form. All right, so hopefully that helps. And if it did, if you don't mind checking out our website, glazersguide.com, maybe even liking and subscribing would help us out tremendously. And we want to help you as well. Check out what we got. We'll see you over there.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.